Hello and welcome back. Look, if you're gearing up for your Cambridge computer science exams anytime soon, and I'm talking about syllabus 9618, 0417, 0478, 0983, 0984, or 2210, then you have literally just clicked on the most important explainer of the year. Seriously, today we're bringing you the ultimate exam cheat code. We are going to program your brain for maximum efficiency. We're going to completely master section 8.2, which covers database management systems, and specifically, we're zeroing in on the features addressing file-based issues. Now, I want to be super clear right up front, this isn't just about memorizing some textbook facts. Nope. This is about building automated patterns in your mind for those really common question types that trip everyone up. So, get focused, grab a pen if you need to, get ready, and let's decode the matrix of these Cambridge exams together. Okay. Let's dive right into this. When we sit down and really look at the principal examiner reports, there is a glaring massive pattern that emerges every single time. Year after year after year, 8.2 database management systems is flagged as one of the single most misunderstood areas across the entire computer science syllabus. It's actually kind of crazy. Students are walking into the exam hall thinking that just having this sort of raw, surface-level memorization of file-based issues, like, knowing what data redundancy is, basically, is going to be enough to get them a passing grade. Well, I'm here to tell you, it's absolutely not. The stakes here are incredibly high. If you're just relying on rote memorization without really grasping the underlying nuts and bolts mechanics of how a DBMS actually functions, you're leaving crucial grade-defining marks sitting right there on the table. But hey, don't worry, because that is exactly what we are going to fix right now.
All right, here is our highly structured algorithmic blueprint for today's session. First, we'll look at the DBMS exam trap. Second, targeting cognitive domains. Third, the method mark strategy. Fourth, our interactive workshop. And finally, the final blueprint and those crucial examiner warnings. Let's get into it.
Starting off with Part 1, the DBMS exam trap. So, we're going to look at exactly why students consistently, almost predictably, drop marks on DBMS questions. Our goal is to transform that vague, floating theoretical knowledge you have into guaranteed, locked-in marks. It's actually fascinating, because when you look at past papers, the mistakes almost always fall into two very distinct, very predictable categories. Let's look at two typical students. Over here we have Alex's approach. Alex sees a question about file-based issues on the paper and immediately panics. What does Alex do? Word vomit. Alex just unloads every single technical term they have ever heard of: program data dependence, isolated data, flat files, the whole shebang. But here's the catch. Alex provides absolutely zero analysis of how a relational model actually solves these specific issues. It's just a list. And guess what? The examiner's red pen goes straight through it, because there is zero context. Then, on the flip side, we have Sam's approach. Sam is watching the clock. Sam rushes the answer, completely misses those absolutely critical command word requirements, words like evaluate or compare, and totally ignores the specific scenario provided in the prompt. Both of these approaches are completely flawed. They lack context, they lack actual deep analysis, and most importantly, they fail to answer the actual question being asked by the examiner. Moving right along to Part 2, targeting cognitive domains. Now, what's really interesting about this slide is it shows us exactly how to avoid the traps that Alex and Sam just fell into. We have to look at exactly how examiners are instructed to award you marks behind closed doors. It's not magic, it's not arbitrary, it's a precise psychological framework. The Cambridge syllabus doesn't just want to test your memory, it specifically targets distinct cognitive domains. These assessment objectives are strictly broken down into three things: knowledge and understanding, application, and critical analysis. Listen, top-performing students, the ones getting the A stars, they understand this theoretical architecture. They do not just list facts, they exhibit this deeply connected conceptual understanding that easily transfers to totally unfamiliar contexts. So when a question asks about how a DBMS addresses data redundancy, an average student is just going to write down a definition of data redundancy. But a top student? They define it, sure, but then they apply it directly to the specific database scenario given in that exam paper. And then they critically analyze how the relational model explicitly solves that redundancy through something like normalization. That clear, causal relationship, that is exactly what gets you the top marks. To hit all of those cognitive domains seamlessly under exam pressure, you need a system. Enter the PEEL framework, specifically adapted for DBMS. PEEL stands for point, evidence, explanation, and link. First, you make your clear point about the database concept. Then, you provide evidence pulled directly from the scenario in the prompt. Next, the explanation. This is the technical mechanism, so you explain how does the DBMS actually function in this specific instance. And finally, link it. The principal examiner reports specifically highlight that candidates who reference cross-topic connections achieve significantly higher marks. So, I'm starting a 30-second mental timer for you right now in your head. Think about the very last past paper you attempted. Be honest with yourself. Which parts of your own extended answers actually followed this specific structure? Did you really explain the mechanism, or did you just state a fact and hope for the best? Did you actually link it back to the question? Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, rolling into part 3, the method mark strategy. Okay, so if the Peel framework is your structure, then this next concept is absolutely your secret weapon. We are talking about algorithmic thinking. This is where marks are awarded for the process itself, not just getting to the final answer. If you want to rewrite those terribly flawed answers from Alex and Sam earlier, you have to follow this exact procedural framework. Step 1, deconstruct the question. You've got to find those command words. Step 2, extract the relevant data from the prompt. Ignore the fluff. Step 3, select your analytical framework. Step 4, execute with clear notation. Step 5, present it all with the correct terminology. Imagine a 60-second visual timer ticking down right now. If you were handed a really complex 8-mark question on the transition from an old flat file system to a relational DBMS, you wouldn't just pick up your pen and start blindly writing. No way. You would spend the first few seconds actively deconstructing. You'd extract the fact that the company has duplicate records causing data inconsistency. You'd select your framework, in this case data integrity and redundancy. Then and only then you execute. It's a highly precise methodical process.
Let's look at how this builds into a systematic processing sequence. This timeline is crucial because it shifts your mindset entirely from simply worrying about what to know to mastering how to process. When you are dealing with data interpretation in DBMS, like, say, extracting information from complex binary representations or evaluating data dictionaries, systematic processing is absolutely critical to your success. You identify the key elements first, then you apply the relevant database principles. You execute your analysis, making sure to show clear working. Then, and people always skip this, you verify your results. Does this actually make sense within the context of a DBMS? Finally, you present it flawlessly. This systematic sequence is exactly how you prove to the examiner that you aren't just memorizing, you are actively thinking like a true computer scientist.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome back. Let's jump into part 4, our interactive workshop.
This is the interactive portion of our session. This is where the theory finally meets practice, and we test your brand new algorithmic framework under some actual pressure. We're going to deconstruct, solve, and evaluate. Here is challenge number 1, the data scan. Now, when you see a really complex chart, a graph, or a complicated set of binary representations detailing database structures on your exam paper, you cannot freeze. The clock is ticking, literally. Imagine that 60-second visual timer on the screen right now, 59, 58, 57. You need to immediately scan for the core trend. Are the file sizes expanding exponentially because of massive data redundancy? Is the search time lagging heavily due to a complete lack of indexing? Your job in that moment is to extract that relevant data instantly, perform the mental calculations, and draw a rock-solid evidence-based conclusion before your pen even touches the paper to write a single word. That right there is algorithmic thinking in action.
All right, let's move right on to challenge 2, find the flaw. Look at this text comparison. Let's read the flawed paragraph. It says, the DBMS uses indexes, which makes searching faster than file-based systems. Honestly, to a lot of people, that sounds okay, right? It sounds true. Well, it's wrong. Look over at the examiner commentary on the right. Loses marks, not specific to the context given in the question, lacks analysis of algorithmic efficiency. This is what I mean when I say vague answers bleed marks. To fix this using our procedural framework, you would need to specify exactly why the index makes it faster. You'd need to explain that it maps keys to memory addresses, which effectively reduces the time complexity of the search operation from linear time all the way down to logarithmic time. And then, and this is the kicker, you have to apply that directly to the customer database that was actually mentioned in the exam prompt. Context is king here, guys.
So the crucial point is that those higher-order assessment objectives actively demand that you evaluate algorithm quality. Look at this table for a second. If an exam question asks you to evaluate a specific approach within a DBMS, you must systematically check these 3 areas. No exceptions. First, time complexity. What is the execution speed, and how do you explicitly justify its efficiency? Second, space complexity. What is the memory usage like here? Are you actively comparing different data structures? And finally, edge cases. Have you considered the boundary conditions? Have you provided rigorous proof of testing? This exact deconstruct, solve, evaluate method is literally the dividing line that separates the A-star students from everyone else in the room.
And now, we reach our final section, Part 5, the final blueprint and examiner warnings.
So, we've built the system together, we've tested the framework, and now it is time to summarize the overarching strategy and reveal the most critical warnings pulled directly from Cambridge Principal Examiner reports. Treat these next 3 points as your ultimate what not to do guide. I'm delivering these with a very high-stakes warning because I see brilliant students make these exact same mistakes every single day. Number 1, answers on 8.2 DBMS are often way too vague. The examiners are practically begging for specific technical details, like data consistency mechanisms and actual security protocols. Number 2, students constantly forget to check boundary conditions and edge cases. Listen, when you propose a database solution on paper, you have to ask yourself, what happens when it breaks? What are the absolute limits of this system? And number 3, answers are generic. If the question on the paper is specifically about a hospital's patient database, your answer cannot just be about some generic, nameless business. If your answer isn't firmly rooted in the specific context provided, you are not getting the marks. It's that simple.
And look, if you take absolutely nothing else away from this entire explainer, I need you to permanently encode this final warning into your brain. The report states, examiner alert. Candidates consistently confuse key terminology. I'm telling you, confusing terminology is the absolute fastest way to drop entire grade boundaries. If you accidentally swap the term data dependence with data redundancy because you're rushing, the examiner immediately assumes you fundamentally don't understand the topic. They won't give you the benefit of the doubt. So always define your terms clearly before you start throwing them around in your extended responses. Prove your foundational knowledge to the examiner first, and then build your argument.
All right, here is your ultimate cheat sheet recap. This is your complete computer science success blueprint. If you follow these 3 rules, you are programming yourself for top marks. Rule 1, command word decoding. You have to know exactly what the question is asking you to do before you start. Rule 2, Peel framework application. Point, evidence, explanation, and link. Use it to structure every single extended answer flawlessly. Rule 3, time management matrix and systematic processing. Deconstruct the prompt, extract the data, and execute efficiently. The data doesn't lie. Students who actually implement these specific computer science strategies see an average improvement of 2 full grade boundaries. But, and this is a big but, that only happens if they practice consistently with our weekly explainers.
Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below right now with your target grade for computer science and the absolute biggest challenge you're facing right now. Our team responds to every single comment, so let us know how we can help. Also, make sure to like and share this session with a study partner who needs to hear this. Ace the Exams. Your Cambridge success starts here. But hey, before you close this tab, ask yourself one last thing. If your school's entire database was still running on an old flat file system tomorrow morning, exactly how quickly do you think it would break? Think about it. I'll see you in the next explainer.